We've never had a chance to study these ancient frozen relics of solar system formation that we think has so much to teach us about how the planets formed and what the material is that the planets formed from. We're going to map it in color. We're going to map it in stereo so we get the heights of all the features. We're going to map its surface composition. We're going to search for satellites. We're going to search for rings. We're going to search for an atmosphere around Ultima. And by the time New Horizons leaves with its data banks full from the flyby, we should have on board enough information for the first time to really understand what Kuiper Belt objects are all about. This is a more difficult flyby than the one that we did at Pluto. The spacecraft power levels are lower, and because the spacecraft is farther away, the round-trip communications times are longer. Then add to that this target is 100 times smaller than Pluto, so it's fainter and it's harder to track. Those three things conspire together to make this a much more challenging flyby. On a human scale, exploring 4 billion miles from home is almost unimaginable. It's such a gigantic distance. This is at the very frontier of our solar system, at the edge of the planetary system, and we think it's going to be more than just a scientific bonanza. It's going to be publicly engaging. It's going to be inspiring to children to go into engineering, science, and math careers. And we think that this kind of exploration shows us what humans are best at, is creating knowledge and understanding the world around us. After we finish the flyby of Ultima Thule, New Horizons will begin to transmit all the data that it's taken back to Earth. But that process is going to take more than a year and a half. It'll be late in the year 2020 before we finish that. And then the spacecraft, if it remains as healthy as it is now, we know that it has the power and the fuel to go on exploring for perhaps another 20 years.